To estimate the service size for a mobile home complex, we need to follow a few steps. Firstly, determine the total amperage. This involves calculating the sum of the amperage of each individual unit service panel. In this case, we're assuming each unit has a 200 amp service panel and there are 89 units in total. Therefore, the total amperage is 200 amps per unit multiplied by 89 units, resulting in 17,800 amps. Secondly, apply a demand factor. The demand factor accounts for the fact that not all units will be drawing their maximum load simultaneously. This is a crucial step in preventing overestimation of the required service size. For mobile home complexes, a demand factor of 0.7, which is 70%, is typically applied. To adjust the total amperage, we multiply the 17,800 amps by 0.7, giving us an adjusted total amperage of 12,460 amps. Thirdly, calculate the service size. Using the adjusted total amperage, we can now determine the appropriate service size for the mobile home complex. A typical voltage for mobile home complexes is 240 volts. To find the service size in kilovolt amperes, or kVA, we divide the adjusted total amperage by the voltage. So 12,460 amps divided by 240 volts gives us a service size of 52.33 kVA. Therefore, the estimated service size for the mobile home complex is 52.33 kVA. It's important to note a few things. Firstly, it's always advisable to consult local electrical codes and regulations for specific requirements. These codes may vary depending on the location and can impact the final service size calculation. Secondly, peak load calculations may be necessary in some cases, especially if there are significant energy-intensive appliances or equipment present in the complex. These peak loads can influence the overall demand and should be considered. Thirdly, when selecting a service size, it is crucial to consider future expansion or load growth. This will ensure that the electrical system can accommodate any potential increases in demand without requiring costly upgrades in the near future. In summary, to calculate the service size for a mobile home complex, firstly, determine the total amperage by multiplying the amperage per unit by the number of units. Secondly, apply a demand factor, typically 0.7 for mobile home complexes, to adjust the total amperage. Thirdly, calculate the service size by dividing the adjusted total amperage by the voltage. Remember to consult local electrical codes, consider peak load calculations, and account for future expansion when selecting the final service size. The calculations presented are estimates, and consulting with a qualified electrician or engineer is recommended for accurate service sizing and compliance with local codes. Demand factors can vary based on local codes and the specific characteristics of the load. The 0.7 demand factor is a common starting point, but it's essential to verify its appropriateness for the specific jurisdiction. Peak load analysis involves assessing the maximum possible load that the complex might experience at any given time. This requires considering the types of appliances and equipment used in each unit, as well as their usage patterns. The service size should be adequate to handle this peak load without overloading the system. Consider the long-term implications of the service size selection. If the complex is likely to grow in size, or if residents are expected to use more electricity in the future, it's wise to choose a larger service size to accommodate these potential increases in demand. The voltage used in the calculation is crucial. While 240 volts is a common voltage for mobile home complexes, it's essential to confirm the actual voltage used in the specific location. Using the wrong voltage can lead to an inaccurate service size calculation. Ensure that all electrical work is performed by qualified and licensed electricians. They have the expertise to properly size the service and install it in accordance with all applicable codes and regulations. Electrical codes are constantly evolving, so it's essential to stay up to date with the latest requirements. This includes changes to demand factors, wiring methods, and safety standards. Electrical safety is paramount. Ensure that all electrical equipment is properly grounded and that appropriate safety devices, such as circuit breakers and ground fault circuit interrupters, are installed. Regular inspections and maintenance are essential to ensure the continued safe and reliable operation of the electrical system. This includes checking for loose connections, damaged wiring, and other potential hazards. Understanding the different types of electrical loads is important for accurate service sizing. This includes lighting, heating, cooling, appliances, and other equipment. Each type of load has its own unique characteristics that must be considered. The demand factor is a statistical measure of the diversity of the load. It represents the ratio of the maximum demand of a group of loads to the sum of the individual maximum demands of the loads. A lower demand factor indicates a higher degree of diversity, meaning that the loads are less likely to be operating at their maximum demand simultaneously. The service entrance conductors must be sized appropriately to carry the calculated load. The National Electrical Code, or NEC, provides guidance on the proper sizing of conductors based on their ampacity and other factors. The overcurrent protection devices, such as circuit breakers and fuses, must also be sized appropriately to protect the service entrance conductors and the downstream circuits. These devices should be coordinated to ensure that they trip in a selective manner, minimizing the extent of any outages. The grounding system is a critical component of the electrical system. It provides a path for fault current to flow back to the source, allowing the overcurrent protection devices to trip and clear the fault. The grounding system must be properly installed and maintained to ensure its effectiveness. Bonding is the process of connecting all metallic parts of the electrical system together to create a low impedance path for fault current. This helps to prevent dangerous voltage differences from developing between different parts of the system. Surge protection devices, or SPDs, can help to protect sensitive electronic equipment from damage caused by voltage surges. These devices should be installed at the service entrance and at other strategic locations throughout the electrical system. Power quality is an important consideration for modern electrical systems. Poor power quality can lead to equipment malfunction, data loss, and other problems. Power quality monitoring equipment can be used to identify and address power quality issues. Energy efficiency is becoming increasingly important as energy costs rise and environmental concerns grow. There are many ways to improve the energy efficiency of an electrical system, such as using energy-efficient lighting, appliances, and equipment. Renewable energy sources, such as solar and wind power, can also be used to reduce reliance on fossil fuels. Electrical system design is a complex process that requires careful consideration of many factors. It's essential to work with qualified and experienced professionals to ensure that the electrical system is safe, reliable, and efficient. The local utility company may have specific requirements for service connections and metering. It's important to coordinate with the utility company during the design and installation process. Permits are typically required for electrical work. It's important to obtain all necessary permits before starting any work to avoid delays and potential fines. Inspections are typically required after electrical work is completed. It's important to schedule inspections to ensure that the work has been done correctly and in accordance with all applicable codes and regulations. Documentation is essential for electrical systems. This includes drawings, specifications, and operating manuals. Proper documentation can help with troubleshooting, maintenance, and future upgrades. Training is essential for anyone who works on electrical systems. This includes electricians, technicians, and maintenance personnel. Proper training can help to prevent accidents and ensure that the work is done correctly. Safety is always the top priority when working with electricity. Always follow safe work practices and use appropriate personal protective equipment, or PPE. Lockout, tagout, or LOTO procedures should be used to de-energize electrical equipment before working on it. This helps to prevent accidental energization and potential injuries. Arc flash is a dangerous phenomenon that could occur when electrical equipment is energized. Arc flash can cause severe burns, blindness, and even death. Arc flash hazard assessment should be performed to identify potential arc flash hazards and to determine the appropriate PPE. Electrical safety programs should be implemented to promote a culture of safety in the workplace. These programs should include training, procedures, and audits. Continuous improvement is essential for electrical safety. Regularly review and update electrical safety programs to ensure that they are effective and up to date with the latest codes and regulations. Firstly, ensure proper grounding. Secondly, use ground fault circuit interrupters in wet locations. Thirdly, inspect electrical cords regularly. Fourthly, avoid overloading circuits. Fifthly, keep electrical panels clear. Sixthly, turn off breakers before working on circuits. Seventhly, use appropriate personal protective equipment. Eighthly, follow lockout/tagout procedures. Ninthly, stay updated on electrical codes. Tenthly, hire qualified electricians. When calculating the service size, consider the impact of electric vehicle charging. As electric vehicles become more popular, the demand for charging stations will increase. The service size should be adequate to handle the additional load from electric vehicle chargers. Load management systems can be used to optimize the use of electricity and reduce peak demand. These systems can automatically shed loads during peak periods, preventing overloads and reducing energy costs. Smart meters can provide valuable data on electricity consumption patterns. This data can be used to identify opportunities to improve energy efficiency and reduce costs. Demand response programs can provide incentives for customers to reduce their electricity consumption during peak periods. These programs can help to reduce strain on the grid and improve reliability. Distributed generation, such as solar and wind power, can help to reduce reliance on the grid and improve energy security. However, it's important to properly integrate distributed generation into the electrical system to ensure its safe and reliable operation. Microgrids are localized electrical grids that can operate independently from the main grid. Microgrids can provide greater resilience and energy security, especially in areas that are prone to outages. Energy storage systems, such as batteries, can be used to store excess electricity and release it when needed. Energy storage can help to improve grid stability, reduce peak demand, and increase the use of renewable energy. The Internet of Things, or IoT, is transforming the way we manage and use electricity. IoT devices can be used to monitor energy consumption, control appliances, and optimize energy efficiency. Cybersecurity is becoming increasingly important as electrical systems become more interconnected. It's important to protect the electrical systems from cyber attacks to ensure their safe and reliable operation. Predictive maintenance can be used to identify potential equipment failures before they occur. This can help to prevent outages and reduce maintenance costs. Data analytics can be used to analyze large amounts of data from electrical systems to identify trends and patterns. This information can be used to improve efficiency, reliability, and safety. Artificial intelligence, or AI, is being used to automate many tasks in the electrical industry. AI can be used to optimize grid operations, detect faults, and improve energy efficiency. Blockchain technology can be used to create a secure and transparent platform for energy trading. This can help to facilitate the integration of distributed generation and microgrids. The future of electricity is likely to be more distributed, decentralized, and decarbonized. These trends will require new technologies and approaches to electrical system design, operation, and maintenance.